I'm very excited to look at the next session right now. The session is titled AI to do AI. It's automated machine learning and the future of data science. The speaker is Vinod Iyengar. Vinod is the VP of Marketing and the Head of Strategic Alliances at H2O. He leads all product marketing efforts, new product development, and integration with partners. Vinod comes with over 10 years of marketing and data science experience in multiple startups, and he is currently with H2O.ai. Thank you so much, Vinod. Over to you.
Thank you, Rahul, for the kind introduction. Thank you, everyone, for logging in and checking out the summit. It's been an amazing event so far. Some really good speakers have come earlier, and then more to come. So let's quickly get into this topic, AI to do AI, and talk about the automated future, like the future of machine learning and data science, which is automated machine learning. So before I start talking about us, we'll talk a little bit about the company. I work at H2O.ai. We are a leader in AI and ML. And here are some of the reports. The Gartner MQ for data science platforms, they put us as a visionary. The Forrester Wave for automation solutions that Mike earlier referred to. We are a leader in that space as well. And then the EMA report calls us one of the top 3 vendors for AI and machine learning. But more importantly, what we really care about is our growing open source community. So we've been in business for about 7 years, and over 18,000 companies currently use H2O open source. That also includes nearly half of the Fortune 500, which also has a lot of the top 10 banks, insurance companies, and healthcare companies. We have a massive meetup community as well, where over 120,000 meetup members meet on a regular basis every week to create this growing pool of data science and machine learning. Over 200,000 data scientists use us on a regular basis. And on the right, you see some of our customers who have been great references for us. And you can see that it includes a whole bunch of verticals from financial services, healthcare, insurance, marketing, retail, telco, and so on. We'll talk about each of those use cases in a little bit detail down the line. But suffice to say, AI and ML is very widely being used by a lot of our community and a lot of our customers. So let's talk about today's topic, which is why AutoML. So as you can see in the previous slide, we have a huge community of data scientists and companies who are using machine learning and data science. But we still found that there are 3 big challenges towards enterprise AI adoption as we're working with our customers. And those are namely the top 3, right? The talent, time, and trust, as we like to call it. So let me talk about them in a little bit detail. There is a huge shortage of talented data scientists, expert data scientists, if you will. And this is no new news for anyone. And if you heard Mike's talk earlier, he referred to that as well. There's just not enough data scientists coming out of the pool, especially even from schools, even though there's a massive sort of need for them. The other big challenge is that the tooling around data science and machine learning currently can be quite clunky. Even if you have really good products like H2O open source, it can take a lot of time to get models built, trained, create the features, and then deploy those models to production. The whole pipeline can be very slow. And finally, since AI and ML is just becoming more and more mature, there's a lack of trust in black box models, especially when those come with a lot of work that happens under the hood with, say, deep learning or even statistical machine learning techniques. So to solve these 3 challenges, we sort of embarked upon by bringing this AutoML solution for the enterprise. And the way we do it is by attacking each of those problems. So how we solve for talent is by bringing the top data science experts. And in our case, we've actually hired the best Kaggle grandmasters. For those who don't know, Kaggle is a data science portal where companies can post the data and host these data hackathons to encourage people to solve their problems. And we found that some of the best data scientists in the world are out there, and there are about 120 grandmasters who are the best of the best. And we ended up hiring a bunch of those people to take their standard workflows and automate them, basically codify them into the platform, so we can give to our customers the same level of accuracy and performance that you'd get out of a Kaggle grandmaster. The second thing we did is we accelerated the whole ML pipeline by A, automation, but B, also working with our partners like Intel to accelerate the ML algorithms to take advantage of the latest and greatest innovation in software and hardware. So now we can reduce the time it takes from building a model from months to hours. So we can produce a highly optimized pipeline that would have tried hundreds of models and thousands or tens of thousands of features in a matter of hours, and that would have taken a human months of work, right? So that's the time to insight has been dramatically reduced. And finally, after building all these amazing models, the key to getting them approved by both the business stakeholders and also regulators in this case, like especially for verticals like healthcare and financial services, where regulations are very, very key, is to give you full explainability and transparency. And we do this with the whole suite of products, but also helping the end users understand what happened by fully documenting the workflow, telling every single step what happened, and then visualizing that as well to help the business users understand the results of machine learning. And then finally, giving them reason codes on every single prediction we make. And that's critical because then you can explain to the business and also to regulators why you made a prediction. So with that, let's come to basically how we solve that with driverless AI. But before I talk about our own product, let me also talk about the key considerations if you're embarking upon machine learning or AutoML, as it's being popularly called. Excuse me. So the top considerations for AutoML, in my opinion, are a few, right? So first, consider, can you automate the entire workflow or automate as much as possible? So that is the machine learning part, the modeling part, but can you also automate feature engineering? Can you automate the interpretability, the deployment aspects of it? So that becomes critical. Think about full automation as much as possible because then you can make your existing teams much more productive. Secondly, considering whether your automatic machine learning platform and even your ML platform overall can be run in a portable fashion. So you want to be able to run this very close to your data. So it should be able to run on the cloud, run on-prem, run on different environments, hardware and both software environments, infrastructure-wise, right? So having the flexibility to run this in different places is critical. The third important piece is how extensible is your platform. There's no point in buying a monolithic platform that doesn't extend you because as new and new techniques start coming up, you want to be able to add new transformations, add new models, add new algorithms, and also optimize it for your business-specific problem, right? So the key is to find out if the platform can be extended. And then think about future-proofing. Can you handle new technologies as they come in, right? So the space of AI/ML is rapidly evolving. New techniques get put out by literature, by academia all the time, and you want to be able to take advantage of these latest and greatest technologies. So consider a platform that can help you go through the entire workflow is critical. And finally, explainability, trust, and transparency is important. You want to be able to understand the whole workflow because that will give you a lot of confidence when you explain the results to the business or the regulators. So with driverless AI, we set out to do exactly that, basically using AI to do AI. So we automate the entire machine learning workflow and giving every data scientist, both junior and senior data scientists in an organization, all the tools to be extremely productive and successful. That means we automate the entire workflow from feature engineering, modeling, visualization, and interpretability. We also are able to generate automatic standalone scoring pipelines that can convert your data to code essentially. So you go from raw data to a modeling artifact, which essentially gives you the results of all the intelligence there in the data. And finally, helping explain the results and visualizations in a single platform, right? So that's driverless AI for you. So let's look at how it works in practice, right? So on the left, you see a whole bunch of different data sources. And this is very common. Your data might be in different places like HDFS and SQL databases, sometimes in on-prem data sources or even cloud data warehouses like Snowflake, Google BigQuery, or Amazon Redshift or Blob Storage, right? Wherever the data is, and we have a whole bunch of connectors. So you pull the data from wherever the data is, bring it into a modeling-ready data frame, essentially. At that point, you want to run through what's called exploratory data analysis, EDA, as data scientists like to call it. And this involves basically understanding the data, looking for missing values, outliers. And this helps you fix the data back. So a large part of your data science workflow is data prep. So we providing the tools to make it really easy. That's critical. Once that's done, we run through automatic model optimization. So as you can see, it's very straightforward. You literally take the data, prep it a little bit, and then you give it to the automatic modeling platform that'll run through feature engineering, algorithm selection, model tuning, and the whole pipeline is optimized iteratively. What that involves then is actually figuring out the type of problem and applying the right recipe. So that's what driverless AI does. So for example, if it's an IID problem, you apply a whole different set of techniques to solve the problem as compared to, let's say, if it's a time series problem or an NLP problem. So for example, if it's an NLP problem, you want to apply deep learning techniques that are very optimized to solve these problems very well. So picking the right algorithms, picking the right recipe essentially is critical, and that's what driverless AI does, and you want that in your AutoML platform. Once that's done, you get an automatic scoring pipeline which is optimized for low latency, so you can go to production directly. And when you get that, in parallel, you also get full documentation of what happened. So you get to see what choices the software made, what algorithms it picked, what feature engineering it did, and what final pipeline it produced for you. So you can then go back and sort of reproduce the model if you want to, but also explain and document what exactly happened. So when we want to explain the results of a prediction to someone, you have the full trail. And finally, interpretability is critical. Machine learning interpretability is a really advanced, like fast-growing space where there are a lot of new techniques coming to the market. Understanding if your software can take advantage of those latest innovations and help explain the results of machine learning is critical. And we do that automatically out of the box in H2O driverless AI. Now let's look at some of the use cases. So what does it translate to from an industry perspective, right? The proof is in the pudding. So we have taken automatic machine learning, driverless AI, and applied it to a whole bunch of different verticals. And we'll talk about 3 verticals today in a little bit detail. So first is financial services. This is our biggest vertical by far, and we have had phenomenal success in some of the largest banks in the country, including folks like Wells Fargo, Citibank, Capital One, who are running through a whole bunch of different use cases on H2O and driverless AI. And some of them include basically around wholesale commercial banking, so things like KYC, Customer 360, for example, or anti-money laundering. The anti-money laundering is a big issue, and we are seeing phenomenal success with machine learning, especially driverless AI, to solve anti-money laundering use cases in some of these large banks. On the cards payment sides, fraud detection has always been a big use case. Risk and fraud are traditionally been the most widely used use cases for data science and machine learning for H2O, but we're seeing all kinds of interesting things like collusion fraud, real-time targeting, credit risk scoring, for example, is becoming very important, and doing that for new types of data, unstructured data, data coming in from non-traditional data sources, right? So though we are able to solve for those use cases as well. Finally, if you get into the IT infrastructure side, cybersecurity is critical. So denial of service detection or intrusion detection, spam filtering, those are big use cases that we're able to solve with machine learning. On the retail side, deposit fraud detection, customer churn prediction are key use cases as well. So you can see there's a whole bunch of use cases on the financial services side that we're able to solve today. Let me talk about one of the vertical, which is again a big vertical, growing vertical for us, is marketing and retail. And over here we see a whole bunch of again great advancements, that amazing things that our customers are doing. Anywhere from increasing sales by cross-selling, upselling, giving them promotions, next best offers, recommendations. On the customer loyalty side, personalizing the platform entirely for the user. And one of great use cases, one of the large e-commerce platforms, they essentially customize the entire page. So all the placements, all the products and offers are customized. So when you as a user go in, you'll see a completely different page from what your friend might see. And that's because they're able to detect and identify what your likes are and optimize that page for you. And that's the level of transformation we're talking about with AI and machine learning. Then on the marketing side, ad placements, investments, or lead funnel improvements. Another amazing use case that we like to talk about that G5 mentioned over there is they are able to, when they get a call at the call center, automatically detect whether the call, based on the tone of the voice and based on the language and the interaction with the agent, whether this is going to be a hot prospect or not. And based on that, they're automatically able to flag it, let their customer reps know that this is a hot customer and offer them a better offer. And this has led to some massive improvement in increase in revenue and savings in costs for them. Finally, let me talk about healthcare, which is again a key vertical for us, and one that we've very invested in, obviously, because it affects the way we live, right? So again, you can do a whole bunch of use cases again with payers, providers, pharma companies, drug manufacturers, and you can do things like, for example, flu season prediction, predicting how many people are going to get the flu and each zip code, for example. That gets very, it's a classic time series problem. We are able to do that automatically with our time series engine in driverless AI, detect when on each day or each week of the year, how many people are expected to enter the clinic in a zip code, for example. Similarly, with early detection of diseases, we are doing some phenomenal work by actually helping understand which patient is likely to get a certain type of disease or certain type of condition based on their past information. And that also leads to things like personalized drug matching, for example. That becomes critical. One other big use case that's been a huge success for us is the ER, emergency room and patient management, patient monitoring systems. So whenever you enter the ER of a hospital, the triaging room, now we are able to, using the data, patient's vital stats and their past information, detect if the patient is going to have an elevated condition and in what time frame. And using that information, we are able to assist the doctors make the right recommendations and help reduce mortality by a significant margin. We're talking about nearly an 80% reduction in mortality from ER to next stage. And those are massive use cases, and we see some great logos down the bottom of the slide. These are use cases which have been successfully implemented and done by the companies. So with that, I want to thank everyone for attending this use case and the opportunity. I want to thank Rahul, Tech Mahindra, and the Intel Capital folks for giving us the opportunity to talk about these use cases. AutoML can help you bridge the gap from ideas to machine learning in production very easily. So I encourage you to all to try it out. Thank you.